Hi everyone, this is Mr. Ruhoy, and this is an Algebra 2 video for trigonometric identities. In this video, I'm going to show you how you can apply trigonometric identities, such as the Pythagorean trig identity, and also an identity for tangent, and how you can apply that to find values of our other trig ratios. In examples 2 and 3, those are more review questions where I go over how to evaluate sine and cosine at different angles, and how you can use reference angles to justify those answers. Let's start with our first example here. So using the Pythagorean identity, given that cosine theta is equal to 0.4, and that our angle is between 3 pi over 2 and 2 pi, find the values of sine and. So the first place we want to start with is determining which quadrant we're in, and that's what the 3 pi over 2 and 2 pi are telling us. If you want to convert from radians to degrees, because it's a little easier to think in terms of degrees, what you can do is you can replace pi with 180, because that's what pi represents when we're talking about angles. So we can do 3 times 180 over 2, and then 2 times 180, and that tells us that we're between 70 and 360. And those angles will place us in the fourth. Now that's very important because that tells us that not only cosine is positive, but sine is going to be negative. And that's the first thing that we're going to be solving for. So when we solve for it, we have to make sure that we show that sine is going to be equal to a negative value. And this also makes sense because cosine, according to all students take calculus, if we're in the fourth quadrant, cosine should be positive. And if you look back at the original question we were given, it says cosine is equal to a positive. So that checks out. Cosine should be positive in the fourth quadrant. That's what we were given, a positive value. So let's get started with the question. We want to use the Pythagorean trig identity. That's sine squared plus cosine squared equals. And that's derived from the Pythagorean theorem, which is a squared plus b squared equals c. And now we want to substitution. We were told that cosine is equal to 0. I wrote it as 4 over 10 as a fraction so that we can kind of get a exact value. So that, because when you're dealing with decimals, sometimes there might be rounding involved, and when you round, you don't get an exact value. So I prefer fractions in that kind of case. So you can subtract 4 over 10 squared from both sides. Write that as 16 over. And one thing I'll just write this in now that I did was I would take the 1, place that with 100 over 1. That I can subtract that. I can subtract the 16. And that would give me 84 over. So that's where that comes from. Now, we're not solving for sine squared, we're solving for sine. So we're going to have to take the square root of both sides. And when you take the square root of both sides of an equation, you have to write plus or minus because it's equal to both the positive and negative values. But the thing is, when you have a sine value for an angle, certain quadrant, it's not equal to both a positive and negative. It's only equal to one of those, either positive or negative, not both. So we're going to have to make a choice, a decision about whether sine's going to be equal to a positive or negative value. And that depends on what quadrant we're in. Before I mention that, go through that, I just want to point out that I simplified this a little. You take the square root of a fraction, you're taking the square roots of both the numerator and denominator. So the square root of 100, that's 10. That part's easy. But the square root of 84, not a perfect square, but you can simplify it. Factors of 84 would be 4 and 21. And the square root of 4 is 2. So that's for the. And then you leave the rad 21. Now, figuring out whether this is a positive or negative, I just want to go back to what we said earlier. We're in the fourth quadrant. So all students take calculus reminds us that cosine is positive, fourth quadrant. That means that all other trig ratios are going to be negative. Sine and tan are negative. And I just want to remind you that the reciprocal of cosine secant is also going to be positive. But then the reciprocals of sine, cosecant, that will also be negative. And the reciprocal of tan, which is cotangent, is also going. So the reciprocal trig functions follow the sine, cosine, and tan ratios do as well. Anyway, sine's negative in the fourth quadrant, as we just said, so we have to get rid of the plus and minus and write it as negative. So we have negative 2 rad 21. That's what sine theta is equal. So now we need to figure out what tan is. You could, if you wanted to, you could just create a bow tie triangle in the fourth quadrant, label each of the sides, and you could figure out what tan is, opposite over adjacent. I also wanted to show you how you can apply another trig identity, which is that tan is equal to sine over cosine. And that identity comes from the circle. Tan is opposite over adjacent in the unit circle. That would be y over x. And we know sine corresponds with y, and then cosine corresponds with x. That's where that comes from. It comes from the... And we can use this identity because we know that sine is equal to negative 2 rad 21. That's what we just solved for. And we know that cosine is equal to 4 over 10. And this looks a little messy, but one thing we can do if you have a fraction being divided by a fraction, is you can do a keep change flip. So we can do negative 2 rad 21 times reciprocal 10 over 4. 10's divide out. You can simplify it a little bit further, and you can finally get an answer of negative rad 21 over. And that's what tan is the same as. That's what it's equivalent to. All right, so let's take a look at our second example. Now this one, I just want to evaluate cosine of 240. And if you type that into your calculator, you're going to see that your calculator gives you a negative 0.5, which is negative 1/2. And that's it. That's how you evaluate it. You can just use your calculator. But let's say you didn't have a calculator. Then what you can do is sort of go through the process of graphing where this angle is. 240 is between 180 and 270, so that places it in the third quadrant. And you can see I labeled where that angle is. Now, if you want to, you could find the reference angle. Now, reference angles, you have the rules for the reference angles that I wrote out right here. And you can see that in the first quadrant. And just a reminder, reference angles are positive acute angles. And the way you can determine what your reference angles are is by, in the first quadrant, your angle. Because if you're in the first quadrant, angle's going to be acute. All those angles are less than 90. In the second quadrant, you want to do 180 minus your angle. In the third quadrant, that's where we are for this. You want to do the angle minus 180, and that's what I have here, 240 minus 180. In the fourth quadrant, you do 360 minus angle. Those are the reference angle rules. So we're in the third quadrant, so 2 minus 180. That means that our reference angle is 60. That's the angle that you would use if you're in the quadrant and you want to construct a bow tie. The angles we use with the bow tie triangles are always closest to the origin, and they're the reference angles. I just wanted to point that out. Now, to justify the answer we got all the way at the beginning of this problem, well, the cosine of 60 is 1/2. That's one of the values you should have memorized, but if you don't, your calculator can always recall them. So how does this help us? Well, the cosine of 60 is 1/2, but also we're in the third quadrant. So according to all students who take calculus, that means that tan is positive, and it means that sine and cosine are going to be negative in the third quadrant. So the cosine of 60 is 1/2, but because third quadrant, that means that this is a negative value. That's why your calculator, all the way at the beginning of this problem, That's why your calculator gave you negative 1/2. It knew what the reference angle is. It had memorized that the cosine of 60 is 1/2, but it also knew that 240 is in the third quadrant. That's why it became negative half. I have one more example of this. Evaluating the sine of 315. So if you put that into your calculator, you're going to get approximately negative 0.7071, which I rounded to 4 decimal places. And if you recall, 0.707, that's equivalent to exactly rad 2 over 2. But your calculator is giving you a negative 0.707. Means that the sine of 315 is negative rad 2 over 2. Now where does this come from? Well, just like the previous question we did, 315, if we wanted to draw where that is, that's in the fourth quadrant. Now, if we wanted to figure out what a reference angle is the angle you'd use for a bow tie triangle. If we were to figure out what that is, the rules that we saw in the last slide, that in the fourth quadrant, you do 360 minus your angle. So if we did 360 minus 315, you'd get a reference angle of 45. Now, one of the trig ratios that you should have memorized, but if you don't, it's okay, your calculator does, is that the sine of 45 is rad 2 over 2. So why is it that our calculator gave you, all the way up here, why is it that it gave you negative rad 2 over 2? Well, it knew that we're in the fourth quadrant. And according to all students take calculus, cosine's positive in the fourth quadrant, which means that sine and tangent are negative. So that's why your calculator, it didn't just give you a positive rad 2 over 2. Because it's sine and sine's negative in the fourth quadrant, it gave us a negative rad 2 over 2. All right, that's about it. Thanks for watching.